Hey everybody, Jeff Oriyama here. Welcome to Bad GraphQL Takes. Today we're taking a look at this article, Why After 6 Years I'm Over GraphQL. This was published a couple of years ago, but still valid, still hear some of these points today. Let's hop right in. So the author starts with a bit of a preamble. GraphQL is an incredible piece of technology that has captured a lot of mind share since I first started slinging it in production in 2018. So they go back a little ways. You won't have to look far back on this rather inactive blog to see I previously championed this technology after building many a React SPA on top of a hodgepodge of untyped JSON REST APIs. I found GraphQL a breath of fresh air, me too. I was truly a GraphQL hype train member. However, as the years have gone on, I have had the opportunity to deploy to environments where non-functional requirements like security, performance, and maintainability were more of a concern. My perspective has changed. In this article, I would like to take you through why today I would not recommend GraphQL to most people and what I think are better alternatives. Throughout, I will use Ruby code with the excellent GraphQL Ruby library, +1 for that library, for examples, but I believe many of these problems are ubiquitous across choice of language / GraphQL library. If you know of better solutions and mitigations, please do leave a comment. Now let's begin. Well, I guess I'll leave my comment here. Okay, so the author clearly has used GraphQL in production. As a preamble here to my commentary, I would say the author, and they're not alone in this, right? Software engineers do this. We tend to think of ourselves. That is to say, we get tunnel vision sometimes, we're in the job and we're thinking about our stack, the tools we're working with, the files we're working in day to day, when in an ideal world, we'd be thinking from first principles from the user's point of view. GraphQL, even in the spec itself, talks about being product-centric and talking about user needs and being flexible to those. And it's through that lens that we really have to consider GraphQL or any API technology as ultimately serving a user. So when we think about security, performance, maintainability, sure, we could talk about the ergonomics there and talk about the friction that those imperatives cause to our day-to-day. But ultimately, we do need to think of those as serving the user. And friction can be a force. GraphQL is about designing APIs that are flexible to client needs and the teams that are closest to them. And so there are some kind of necessary compromises that you need to make. But that said, I'll give it a chance and let's press on. So the first area is attack surface. Okay, so let's go in. It was obvious from GraphQL's beginning that exposing a query language to untrusted clients increases the attack surface of the application. Sure. Nevertheless, the variety of attacks to consider was even broader than I imagined, and mitigating them is quite a burden. Here's the worst I've had to deal with over the years. Okay, so right away, what I'm reading here is that the author is considering untrusted clients to be the consumers of an API. Now, most APIs that we work in, that people work in, are not serving untrusted clients. Public APIs are a very small subset of the API development world, and GraphQL definitely increases, I think, the number of considerations you need to make when you're running a public API. So I'm going to take everything that comes after this, and I think you should too, with a grain of salt, because they're not talking about the jobs that most of us are doing, which is serving known clients. And so it's kind of an odd way to start to go with a very small corner of API development. But let's go on. Authorization. Okay, diving right in. I think this is the most widely understood risk of GraphQL, so I won't go into too much depth here. TLDR, if you expose a fully self-documenting query API to all clients, you better be damn sure that every field is authorized against the current user appropriately to the context in which that field is being fetched. Initially, authorizing objects seems like enough, but this quickly becomes insufficient. For example, say we are the X API, and then they give an example of a user and then blocked users and everything like that, and talking about how certain fields might be PII. One wonders how much GraphQL holds responsibility for broken access control climbing to the OWASP. I always say OWASP there. I don't know if y'all do that too. Top 10's #1 spot. Just mentioning that, one wonders is like, that grates me a little bit. Yeah, one does wonder. You're suggesting that, but there's no evidence there. It's just innuendo. I don't know if GraphQL is or isn't there, but just mentioning that just feels a little odd and unfair, to be candid. One mitigation here is to make your API secure by default by integrating with your GraphQL library's authorization framework. Every object returned or field resolved, your authorization system is called to confirm that the current user has access. Okay. Compare this to the REST world where, generally speaking, you would authorize every endpoint, a far smaller task. Okay, so a few reactions to this one. First of all, I think it's a little disingenuous to use a user's endpoint here because GraphQL wouldn't be alone here. I haven't ever seen a user's endpoint that didn't have a ton of conditionals nested in there, depending on context or depending on query parameters, things like that. So any kind of user object that's returned by any API, GraphQL or REST, is going to be littered with a lot of conditional logic, a lot of checks that could be a source of technical debt. They could be vulnerabilities or whatever. So access control with large objects like user objects, for example, are, I think, a problem in whatever API, especially when it's a public API. But no matter what, role-based access control is a challenge, whether you're using GraphQL or not. And yes, authorizing every endpoint a far smaller task, I would tend to agree with that. Part of this is a schema design question too. GraphQL does force you to confront the design of your API upfront. It shifts left, that posture. And so when you're taking a look at the design of your objects, it's an opportunity to consider what objects might contain sensitive data, PII, things like that, and to design your schema around it accordingly. So authorization, certainly a concern, especially if you're running a public API. I don't think GraphQL changes the game too much here, but it certainly adds a field level concern to it. Okay, another bit that people should think about when considering authorization, because I don't see it here, is schema contracts. Schema contracts are a feature of many GraphQL vendor SaaS solutions that allow you to expose a subset of your schema to different client types. That is a tool in the shed for helping to manage access to sensitive parts of a schema. So I don't see that mentioned here, and I do think that that's worth mentioning. Okay, so they talk about rate limiting. Okay, rate limiting. All right, let's give it a chance. With GraphQL, we cannot assume that all requests are equally hard on the server. There is no limit to how big a query can be. Even in a completely empty schema, the types exposed for introspection are cyclical, so it's possible to craft a valid query that returns megabytes of JSON, and they do a query that is circular. Just tested this attack against a very popular website's GraphQL API Explorer and got a 500 response back after 10 seconds. I just ate 10 seconds of someone's CPU time running this, white space removed. 128 byte query, and it doesn't even require me to log in. Okay, so I'm going to pause right there. So the author just talks about eating 10 seconds of someone's CPU time. Well, that 500 response after 10 seconds sounds like it was the product of a configuration on the GraphQL server, and they decided that was an acceptable cost to a public API. I don't see necessarily an inherent problem with that. I mean, it looks like a scare quote type of thing of like, oh my goodness, 10 seconds. I just used 10 seconds of your CPU time. I'm not sure what that's supposed to say other than to just sound scary. Likewise, I'm going to return to the point I made earlier. Most APIs and most GraphQL APIs are not publicly accessible by unauthenticated clients. So the idea that you can just eat a query like this into anybody's production server just feels like a complete misrepresentation of how most APIs work and how most GraphQL APIs work. Okay, let's continue. The author writes, a common mitigation for this attack is to 1. Estimate the complexity of resolving every single field in the schema and abandon queries that exceed some maximum complexity value. 2. Capture the actual complexity of the run query and take it out of bucket of credits that resets at some interval. Sure, those techniques are valid. There's a lot of other valid techniques that are there. Most GraphQL gateways and servers have a lot of knobs to pull when you're talking about dealing with arbitrary queries in production. I think that if you zoom out, though, tweaking those knobs for production is really the wrong mindset for most GraphQL deployments. You should really just be using persisted queries with safelisting, otherwise known as trusted documents. The idea there is, unless you're running, again, a public GraphQL API to unauthenticated clients, which is such an uncommon use case, and one that I think doesn't paint GraphQL in the best light. It's not the sweet spot for what GraphQL is good at. But if you know your clients, which you should, then you should be using persisted queries and safelisting. That means any operation will be disallowed by default unless it's added to the safe list. So the idea that GraphQL is bad to use because running arbitrary queries from untrusted clients is hard. Well, sure, but most of us aren't using it that way. So this misrepresents what GraphQL is actually good for. Okay, let's keep going. This calculation is a delicate affair to get right. It gets particularly tricky when you're returning list fields as length is not known prior to execution. Well, yes, but at the same time, you can do that with REST pagination as well, any paginated endpoint. You can add arbitrary page values. That's something that you can control for in your implementation, but I digress. You can make an assumption about the complexity of these, but if you are wrong, you may end up rate limiting valid queries or not rate limiting invalid queries. Again, if you have a good observability practice, this is something that your engineers will be taking a look at and adjusting to. Continuing, to make matters worse, it is common for the graph that makes up the schema to contain cycles. Let's say you run a blog with articles, which each have multiple tags from which you can see associated articles. Type article, and it talks about tags. And then the meat here is on the related tags, which refers back to itself. And then the author, I won't read this through, it just talks about another kind of gotcha scare quotes code snippet about related tags and infinite nesting. To be here, like, yes, of course, again, assuming that you're running a public GraphQL API, this can be designed around through schema design. Like, for example, you could have a tag and you could have a related tag type that is the same as type tag, but only allows for one layer of nesting. So you could have a tag and then a tag with related tags, and you could expose that. Seems like a perfectly rational way to design a schema so that your top level query can't just do infinite nesting or whatever. Schema design can solve a lot of evils out there in your APIs regardless. So design your APIs accordingly, is what I'm trying to say. Clearly, when you are servicing untrusted clients, these are all concerns. I don't want to paper over them. Like, this is a thing that people have to deal with. To be fair, this is something that if you're running a public GraphQL API, you should design around and observe your system around. I'd say the same is true if you're running a public API, the JSON response with your controllers. Of course, the surface area is a little lower with that. And then they talk about configurations that are common, right? Limiting the nesting of queries and things like that. And then they talk about how rate limiting a REST endpoint is a bit simpler. And I think that's generally not false, right? Rate limiting against individual endpoints is a little simpler than the interconnected nature of a graph API. All right, moving on. Query parsing. So this one's interesting. Again, big asterisk on everything here because I can even see reading ahead, query __ type name with a bunch of directives. So the author says, before a query is executed, it is first parsed. Well, yes, but you can reject those outright if you're using persisted queries with safelisting. So again, this is for a very small subset of GraphQL deployments. They talk about, okay, we once received a pen test report evidencing it is possible to craft an invalid query string that oomed the server, for example. And then they talk about how it's a syntactically valid query that used up a bunch of stuff. Again, this is sort of like scare quotes. Again, most of us are not dealing with these kinds of malicious actors because we're dealing with known clients. So yes, point taken for this specific use case that they're talking about. Okay, performance. This is a hot topic. I see this a lot in comment sections around the internet, so I'm curious what the author has to say about performance. Okay. When it comes to performance in GraphQL, people often talk about its incompatibility with HTTP caching. For me personally, this has not been an issue. For SaaS applications, data is usually highly user-specific, and serving stale data is unacceptable, so I have not found myself missing response caches or the cache invalidation bugs they cause. The major performance problems I did find myself dealing with were, okay, I'll get to that in a minute. I think that actually is a much more nuanced topic than they're representing. GraphQL is not necessarily incompatible with HTTP caching, especially when you're using persisted queries, for example. Also, GraphQL uses normalized caching. Most GraphQL clients do that on the client side. So there's a whole lot of requests that just don't get made because they can be satisfied by a local cache. I, again, agree with the author that caching data can be usually like a strategy that it doesn't always work for certain types of applications. Many GraphQL gateways and GraphQL servers do give you a means of doing response caching out of the box. So again, there's even nuance in what they're conceding GraphQL isn't so bad for. But let's go to the N+1 problem, which is still a thing that people talk about, even though it's a solved problem for the most part. But let's go in. Data fetching in the N+1 problem. I think this issue is pretty widely understood nowadays. TLDR, if a field resolver hits an external data source, such as a database or an HTTP API, and it is nested in a list containing n items, it will do those calls n times. This is not a unique problem to GraphQL, true. And actually, the strict GraphQL resolution algorithm has allowed most libraries to share a common solution, the data loader pattern. Yes, I'm glad that they know that. Unique to GraphQL, though, is the fact that since it is a query language, this can become a problem with no backend changes when a client modifies a query. Again, that assumes that you're letting clients execute arbitrary queries in production, which does not reflect reality for most people with most deployments. As a result, I found you end up having to defensively introduce data loader abstraction everywhere just in case the client ends up fetching a field in a list context in the future. This is a lot of boilerplate to write and maintain. I think that's true. Again, if you are allowing untrusted or arbitrary queries in production, you're not using persisted queries, which most deployments should be using, then yeah, I agree that data loader and the n+1, solving that n+1 problem for a variety of different query shapes can be a real challenge. It just can. That is part of it. With REST, all right, so they're talking about REST, so I'll go ahead and read on before commenting. Meanwhile, in REST, we can generally hoist nested n+1 queries up to the controller, which I think is a pattern much easier to wrap your head around. Yeah, this is all well stated that they're using Ruby. By the way, I love Ruby. Just, it's nice to see Ruby code. I haven't worked with Ruby code in a while. Again, because REST endpoints are typically maybe a little more controlled than arbitrary GraphQL queries, I see their point. I think that they are correct in a lot of ways, particularly when it comes to public APIs. Authorization and the n+1 problem. Okay, that's interesting. But wait, there's more n+1s. If you followed the advice earlier of integrating with your library's authorization framework, you've now got a whole new category of n+1 problems to deal with. Let's continue with our X API example from earlier. And they show a pretty trivial example of an imperative sort of view PII method that will only conditionally return requested fields. This is legit. Again, authorization and n+1 just introduces a new service area complexity to think about, particularly, again, if you are dealing with trusted clients. It's actually trickier to deal with than our previous example because auth code is not always run in a GraphQL context. I'm not sure what kind of code bases or what kinds of auth paradigms they've been using outside of these kind of toy examples. Let me read on. It may, for example, be run in a background job or on an HTML endpoint. That means we can't just reach for a data loader naively because data loaders expect to be run from within GraphQL in the Ruby implementation anyway. I don't really have an opinion on that. I think that might be implementation specific or maybe a property of the code bases that this person has worked in rather than a generalizable point to be made about GraphQL or REST or whatever. In my experience, it's actually the biggest source of performance issues. We regularly find that our queries were spending more time authorizing data than anything else. Again, this problem simply does not exist in the REST world. See, that I do take issue with. This problem simply does not exist in the REST world. Maybe with certain APIs, but I do think that once you reach a certain level of complexity, you're going to have to deal with this and contend with this. Your mileage may vary here. Maybe they're correct from their point of view. I don't know how much a reader is supposed to take away from that particular example. And they talk about, okay, I mitigated this using nasty things like request level globals to memorize data across policy calls, but it's never felt great. Yeah, I guess that doesn't feel great. I don't think that's the only way to do it, but I'll go ahead and play the it depends card that we engineers love to play. Okay, so the performance section has some valid points. I think it's kind of obscuring how much of this is actually GraphQL specific, but point taken there. Like when you're designing an API that's very client-centric, that's product-centric, it requires you to think upfront about kind of edge cases. That is not ergonomic for back-end developers. I'd say that juice is worth the squeeze. And if you're using persisted queries, a lot of these problems are not super relevant, or at least narrows down the service area of what you need to observe and correct for. Okay, so let's go to coupling. In my experience, in a mature GraphQL codebase, your business logic is forced into the transport layer. Okay, so this is not a recommended practice. In GraphQL.org, there is a page on this, how the recommended pattern. Oh, that's right, yeah. And Marc-Andre Giraud wrote a response to this that says that much. I'll put it in the video description. This happens in a number of mechanisms, some of which we've already talked about. So again, business logic should be like auth logic, business logic, everything like that. Don't put it in the transport layer. Okay, let's go through point by point. Solving data authorization leads to peppering authorization rules throughout your GraphQL types. Again, this is not, I mean, if they've done that, that's your business. I'm not sure what a reader is supposed to take away from that because it's not really what folks typically do. Solving mutation/argument authorization leads to peppering authorization rules throughout your GraphQL arguments. Same thought there. Solving resolver data fetching n+1s leads to moving this logic into GraphQL specific data loaders. Okay. And leveraging the lovely relay connection pattern leads to moving data fetching logic into GraphQL specific custom connection objects. That's valid too. Yeah, again, to the previous point, like if you're dealing with public API or if you're dealing with quite a wide variety of different use cases, I think that tracks at least these last 2 points. The net effect of all this is to meaningfully test your application, you must extensively test at the integration layer, i.e. by running GraphQL queries. Found this makes for a painful experience. Any errors encountered are captured by the framework, leading to the fun task of reading stack traces in JSON GraphQL error responses. Since so much around auth and data loaders happens inside the framework, debugging is often much harder as the breakpoint you want is not in application code. And of course, again, since it's query language, you're going to be writing a lot more tests to confirm that all these argument and field level behaviors we mentioned are working correctly. I'm not sure how much we're supposed to take away from that. It sounds like a developer experience question that is less about GraphQL and more about the stack that they were working in or the tools that they were working in. Working in Ruby, I never enjoyed bugger experience. So maybe that's part of this. But again, I'm not sure what a reader is supposed to take from that other than, trying to add fuel to the fire of like GraphQL bad. Okay, and scroll down. Complexity. Taken in aggregate, the various mitigations to security and performance issues we've gone through add significant complexity to a code base. It's not that REST does not have these problems, though it certainly has fewer. It's just that REST solutions are generally much simpler for a backend developer to implement and understand. Okay, so I'll put a giant asterisk here. Again, this is for like public APIs that must serve a lot of arbitrary queries. I do not accept the criticism that the bold, significant complexity is something that is universally felt by most GraphQL developers. I do think that there's a certain level, if I'm going to be charitable here, of shifting left. That is to say, if you're designing a schema and authoring your types and everything like that around a demand-oriented schema, you might be surfacing problems earlier before they reach production. That might contribute to a perceived slower working speed for some use cases. I would argue, though, that that is actually probably a good thing overall because you're creating an artifact that describes to your colleagues the intent behind the design of your API rather than letting that be implicit and having problems kind of sit in the background until a new use case blows up your services. That said, also, they're talking about generally much simpler for a backend developer to implement and understand. True, but that's not why we're here. We're not here to make our lives simple. We're here to make the users' lives better. The GraphQL paradigm is supposed to be more responsive to the user. And I think that juice is absolutely worth the squeeze. Okay, now let's move on. And more, ... So these are the major reasons I am, for the most part, over GraphQL. I have a few more peeves, but to keep this article, I guess, from growing further, I'll summarize them here. GraphQL discourages breaking changes and provides no tools to deal with them. Okay, I think breaking changes are not dealt with by REST either. They're just not. I think breaking changes are context dependent. They depend on the implementation and the clients. This adds needless complexity for those who control all their clients who have to find workarounds. I'm not sure what they're getting at here. If anything, GraphQL is extremely safe because you can observe consumption of the API at the field level and at the client level. So you know precisely what fields are being queried and what aren't being queried. So you know which ones you can deprecate, which ones you can replace, which ones are still in use, and how to deprecate. GraphQL gives great tools for migrating clients to new API fields, to new experiences, to new use cases. So I will respectfully disagree with this. In fact, I think GraphQL does have a tool set because there's the @deprecated directive, and that is an explicit tool for marking intent on a field that has no analog in plain REST API, for example. Okay, next point. Reliance on HTTP response codes turns up everywhere in tooling, so dealing with the fact that 200 can mean everything from everything is okay to everything is down can be quite annoying. That is oversimplified. GraphQL over HTTP does specify response codes other than 200 for GraphQL responses. The fact that they're not mentioning that even after so many years working with GraphQL, I think is either deliberate or maybe they just are getting an incomplete set of information about GraphQL and HTTP conventions. Fetching all your data in one query in the HTTP2 plus age is often not beneficial to response time. In fact, it will worsen it if your server is not parallelized versus sending separate requests to separate servers to process in parallel. Sure, if you're using GraphQL and HTTP, which you don't have to use HTTP, this is valid. Okay, last section, alternatives. Okay, end of the rant. What would I recommend instead? Question mark. To be upfront, I am definitely early in the hype cycle here, but right now my view is that if you, 1, control all your clients. Okay. I have something to say, but let's continue. 2, have fewer than or equal to 3 clients. 3, have a client written in a statically typed language. 4, are using greater than 1 language across the server and clients. Okay, so they just spent an entire article talking about GraphQL in the context of a public, unauthenticated API serving arbitrary, untrusted clients. And now they're saying, in this completely different scenario, I would use a different tool. I'm sorry, that doesn't make any sense to me. Apples to oranges. I can see like this is veering away from GraphQL and talking about OpenAPI, which I love OpenAPI too. Great tech. And they talk about implementation first, specification first, but now we're getting away from the actual GraphQL content here. That is the end of the article. I chose this one first because it made a big splash when it was published and contains a version of some common talking points in software development comment sections. I think the vast majority of this take is relevant only if you're maintaining a public API. The rest of it is valid. My advice for GraphQL practitioners is this. Use persisted queries with safelisting. Use schema contracts. Be intentional with your auth logic. And use GraphQL's type system to encode intent and design thinking into your APIs. If there are any posts, videos, or threads you'd like me to cover in another Bad GraphQL Takes video, please leave a comment. That's it for now. See you next time.